Okay, so good morning, class.
Good morning, Mr. Abuela.
Okay, please be seated. We'll start our lesson with reminders on classroom roles. I would like to emphasize the first five, but I will focus mainly on the third to fifth classroom roles. That is, eyes forward and listen. Then raise your hand if you have something to say, and then be respectful of the ideas of others. Then about the IED guidelines, I would like to emphasize mask and iwas. That is, kinahanglan yung magsunog sang mask tanan aron dili masakdan. And then, di kaya ng pag-sikit-sikit aron nga dili masakit. To start with, we'll start with the objective of the lesson. So the objective of this lesson is for you to be able to explain the different ways in which the distance of celestial objects are estimated using cosmic distance ladder. Okay, we'll start our learning experience with what you know. So this is the directions of the activity. I will show you the questions, then after that you will read carefully and then choose the letter. After I count down from 3 to 0, then when I show my hands like this means what, then you will show your answer using sign language. This is for A, B, C, and D. Again, A, B, C, and D. Kung tanawin ang B, ay natubangan, letter D siya. Okay. Okay, so, mag-count ko sa 3. I'll start with 3, 2, 1, then, hindi ka, ano sa kamot means what, you will show your answer. Okay, ready? Okay, number 1. Okay, ready to show your answer in 3, 2, 1. Okay, so the right answer is A. Okay, let's go to the second question. Show your answer in 3, 2, 1. Okay, the correct answer is B. So most of you got the right answer. Let's go to number 3. Okay, show your answer in 3, 2, 1. Okay, the correct answer is C. Okay, most of you got the correct answer. Let's go to number 4. Okay, show your answer in 3, 2, 1. Okay, the correct answer is B. So, CP, that is nearby galaxy, for the nearby galaxy. Let's go to the next activity. Okay, you'll do the activity by partner. Then, you're going to decode the listed words in the table using the Fishman's decipher. Then after that, we're going to choose from the given options the descriptions that correspond to the decoding or decoded words. So you're given 3 minutes to complete the task. So this is the picture of the graph given to you in the leaflet or in a strip of paper, and then these are the description options. So in the third column, you will write the description, uh, writing the letter of your choice only. So you have here the timer. When I click, uh, the timer will start, and that is the start of the 3 minutes allotted time. Okay, so ready? Okay, so let us answer your work, or let us check your work. Okay, for the first word, the word is, raise your hand. Okay, so the first word is equinox or equinox. Second word is, okay. Okay, the second word is solstice. Third word, Ptolemy. Then fourth word, Copernicus. And the fifth word, Kepler. Okay, so now let's go to the description of each of these words or objects or persons. Okay, which of the following describes the equinox? And Latimon, show your answer by sign language. For A, B, C, D, and E. Okay, so what is your answer? Okay, the answer for this is B. It happens during March and September, and when the length of daylight and nighttime are approximately equal. Okay, second, which of the following describes solstice? Okay, share your answer. Okay, letter D. Okay, the answer is letter D. Letter D, which is 2 days in a year in which the sun is at the farthest inclination north or declination north or south from the celestial equator. Okay, number 3, which of the following describes Ptolemy? Ptolemy. Okay, the answer is he is an advocate of the geocentric or Earth-centered model of the solar system. Number 4, which of the following describes Copernicus? Okay, so the answer is C. He published a revolutionary paper condemning the widely accepted Earth-centered model of the solar system. And of course, lastly, Kepler is credited for formulating the laws of planetary motion. So these are the answers. Let's go to the definition of terms. Terms that we are going to use in our discussion for today. So you do this by pair. Okay, you are given strips of paper, and then you are going to pair or match the terms in one strip of paper, the terms with the definition, with the description. So you are going to match. You are going to pair. You are given 2 minutes to complete the application. Wala na yung mali para ma-application nyo. Okay, go ahead. Okay, the first term is galaxy, which is any of the very large group of stars and associated matter that are found throughout the universe. So, ang galaxy, made up na siya of stars, solar systems. Ating solar system is part of a galaxy, the Milky Way galaxy. Second term is astrometry. It is a branch of astronomy involved in the measurement of distances and motion of celestial bodies. Chicken. Next term is cosmic distance ladder. It is a series of successive methods used by astronomers to determine the distances of distant celestial bodies such as stars and galaxies. The next term is parallax. It is the apparent displacement or difference in the apparent position of an object viewed along two different lines of sight. Then last term, standard candles. Standard candles are objects with no luminosity or intensity of brightness. Sinong naka-perfect? Oh, got a perfect 4. Okay, so you are going to write your name at the back of that piece of bed, and then at the end of the lesson, you are going to deposit that here. So, what is ang alat? So, by kayo naman siya, ang duha. Okay, so let's proceed to the lesson. Okay, so astrometry. Based on the definition, astrometry deals with the measurement of distances and motion of celestial objects. So, in the field of astrometry, we're going to study the distances of celestial bodies. And not only the distances, but their apparent motion, whether it is moving away or moving closer to us as viewers of the celestial bodies. We have here a picture of the Milky Way galaxy. So, our very own galaxy. This is our solar system, and our solar system is located somewhere here. It seems like a tiny block or cold marble in the Milky Way. And imagine there is not only one Milky Way or one galaxy, but there are lots of, say, many or numerous galaxies in the universe. So, the astronomers call it the super clusters of distant galaxies. So, and our solar system is just one part of that, a small part of that. Okay, so, and in the field of astronomy, it was their study to determine the distances of these celestial objects, the stars and the galaxy. So, they're going to determine their distance from the sun, from the earth. In the universe, these are the celestial objects found in our universe. We have the solar system, in which Earth is part of that solar system, and the sun is the center of that solar system. And then next is the stars. Of course, the sun is the nearest star. But there are also, aside from the sun, there are also numerous or 20 nearby stars around us. There is a Milky Way. So, this one in the picture, or this one. So, the Milky Way, which is a galaxy in which our solar system is part of that. And then, aside from the Milky Way, there are also many galaxies. We have nearby galaxy near to the Milky Way, and there are also super clusters of distant galaxies. So, we cannot imagine how vast our universe with just looking up and counting the stars, because beyond the expanse of, say, the space above, there are still lots of stars whose brightness have not reached our Earth. Then, how will we will be able to determine the distances of the celestial bodies, the distance of the nearby stars, the distance of the Milky Way galaxy, the objects, celestial objects in the Milky Way galaxy, the nearby galaxy, and the galaxy clusters. So there is one, say, or there are a series of successive methods that astronomers use to measure the distances, and they call that as the distance or the cosmic distance ladder. So for us to know what is a cosmic distance ladder, I will show you a video about distance cosmic ladder.
The distance ladder is a set of techniques for determining an object's distance. Each step works for a particular situation in distance range and supports the steps above it. This is how we work our way from Earth to the stars and onto the most distant galaxies. We have just built a solid first rung for our ladder. We can now use the entire diameter of the Earth, 12,756 kilometers, as our baseline for triangulating off the Earth and into the solar system. Here's an overview of the rest of the ladder. Parallax is the second rung in the ladder. Direct measurement doesn't work for figuring out how far away the sun is. For that, you use an extension triangulation called parallax. If you hold your finger up in front of your eyes and close one eye at a time, you see a shift in your finger's relative position with respect to distant objects. This is parallax. It can be used to calculate the distance to our solar system neighbors and nearby stars. All you need for this to work is a more distant star that doesn't move when the target object is viewed from different locations. Parallax accuracy goes down as the distance goes up, and it doesn't work at all for stars and galaxies that don't have more distant objects that remain stationary as the Earth-bound observer moves. For those objects, we use a technique called standard candles. Once we know the intrinsic brightness of a star, we can use the simple inverse square rule with a drop-off in the apparent brightness as the object is seen on Earth. Some objects lend themselves to this technique better than others. Some of the most prominent are Cepheid or Cepheid variable stars, emission nebula, and type 1a supernova. These methods can take us across the Milky Way, out to nearby galaxies, and into local supergalaxy clusters.
Okay, so those are the steps involved in the measurements of the celestial objects. Starting with the measurements of Earth, then to the nearest star, the measurements of the Sun, then after that, the nearby stars, then the galaxies. Then from our very own Milky Way galaxy to the nearby galaxies and the galaxies of Earth clusters. Okay, so we'll discuss each of these terms in details. We'll start with what is a cosmic distance ladder. What is a cosmic distance ladder?
Cosmic distance ladder is a very effective method used by astronomers to determine the distance of celestial bodies at the star galaxy.
Okay, so series of successive methods. So a cosmic distance ladder is a series of methods. It means that it is composed of several methods built on one nga dili pwedeng buwag-buwag na kuan. So there as one structure built on one another. And kung sa langit sa tanan, we'll start with the first rung or the first step of the ladder until we come to the topmost step of the ladder. So the same is the process in the cosmic distance ladder. We'll start from Earth, then the nearest star, which is the Sun, the nearby star, then our very own Milky Way galaxy, the nearby galaxy, and then the galaxies of Earth clusters. So it is composed of several methods. Okay, so let's go to the first rung of the ladder. The first rung of the ladder, since this is a series of methods, the first method is triangulation, and ang na siya ang indirect method, triangulation. Para sa direct method, which is radar ranging. So, in indirect method, we will use what we learned in geometry or in trigonometry. Basically, the SOHCAHTUA, the sine, cosine, and the tangent law, which is in the computation of distances, ang pinaka-gamit tayo is the sine law, which is the opposite and the adjacent. So, the astronomers make use of this in the computation of the distance. This is the reason why, even though before the advent of the modern technology, our ancient astronomers were able to measure the distances of, say, the sun, or they were able to compute the radius or the diameter of the Earth using the triangulation method. Okay, so this is one of the major accomplishments in the first round of the ladder, the astronomical unit. What is an astronomical unit?
Astronomical unit is the distance of the Earth from the Sun.
Okay, it is the distance of the Earth from the Sun. And it means that from the Earth to the Sun, the distance is 1 astronomical unit, 1 AU. And how far is 1 astronomical unit in kilometers? In kilometers, 1 astronomical unit is equivalent to 149,800,000 kilometers. Ang na siya ang distance sa Earth from the Sun. So this is one of the major accomplishments in the first round of the ladder. Then later on, their discovery about the distance of the Earth from the Sun was used by them in the computation or in determining the distance of the nearby stars using an extension of a triangulation method which they call parallax. So, ara siya sa angle. The sun is here, the earth is here. Siya yung orbit. So, na-form siya triangle. We form a right angle here. So, given ang angle na rin, so, ang siya opposite, and this is the hypotenuse. So we use the sine law. So ano na siya gigamit sa mga astronomers in the computation of the distance. So this is an extension of the triangulation method. Distance na. Hindi na maabot sa tao, but they were able to compute the distance using the parallax. So what is a parallax?
Parallax is the apparent displacement of an object along two different lines of sight.
Okay, so a parallax is an apparent displacement. When you say displacement, it means relocation. I-transfer ang iyong position, i-transfer ang iyong location from one location to another location. So the viewers transferred his or her location from one point to another point. So, and therefore, he will have two different lines of sight. Okay, for a demonstration, a parallax is simply done by extending your arm and then looking your finger on the background of a distant object. So, for example, this is the background, and then you will watch your finger on the background, first looking with your right eye, with left eye closed, then alternately with your left eye, uh, looking with your left eye and your right eye closed. So what happens to the image? What happens to the apparent position of your finger? It seems to be anong netabo? Daw na balhin. O, daw na balhin. So, the term for that is display. Or, ang iya apparent location was shifted to another location. Tama na siya netabo. That is parallax. And this will only happen if one object is nearer than the other object. Okay, the method that astronomers use in the computation of the distance of nearby star is the trigonometric parallax. So trigonometric parallax. They make use of the trigonometric parallax so that they will be able to measure the distance. So, how parallax is done? Yan sa mga pagkuhan sa parallax.
This is done by mere observation of figures of a nearby star that are within 6 months apart.
This is done by comparing observations done 6 months apart. So, anong kinahanglan man nga observation should be 6 months apart? Why is it necessary that the observation be done 6 months apart?
It will give us a part of the framework of your location of the
Okay, so because after 6 months, the location of the Earth is on the farthest distance from its original location. For example, the original position of the Earth on January is here. Then at the end of June or first day of July, ay na siya mali. So, the distance of the Earth to the Sun is 1 astronomical unit. So, mahimo na siyang 2 astronomical unit. Whereas kung muangkot siya, ang distance is shorter na. Tama na siya, and that is the reason why it should be 6 months apart. So that the astronomer will be able to maximize the distance. The idea is that the farther the distance, the more accurate is their computation. Okay, when you are using parallax, what units of measurements are commonly used?
So light year and parsec.
That
Light year and parsec.
a light year and parsec. What is a light year?
A light year is the distance traveled by light in 1 million years from 7.4 days.
Okay, so the distance traveled in 1 billion calendar, which is 365 and 1/4 days. Tama na siya ang light year. So, distance traveled using the speed of light, and then the time travel, ikaw ma-determine nga amo na siya ang kalayon. So, tungkol sa kalayo, so they make another unit we call light year. But how far really is light year in kilometers? In kilometers, na naman na siya kalayon ang light year.
A light year is a 9,460 billion kilometers.
Okay, so approximately it is 9 trillion. 9,460 billion kilometers. Ang nangyayapad. When written in scientific notation, ang exponent is 12. How far is a parsec in kilometer? Other hands. Wala?
One parsec is 30,839,600 kilometers.
Okay. So, 30 trillion. So, imagine, amo na siya kalayuon i-measure sa mga astronomers. So, 30, na siyang computation. One parsec is equivalent to 3.26 light year. So, ang 1 light year is 9,460,000,000,000. I-times na siya by 326 or 3.26 equivalent to 30 trillion. So, ano na siya kalayuan ang usa lang ka parsec. Up to what distance can parallax be operated? Ang malaki. Okay, less than 100 parsec. For distances beyond 100 parsecs, they will use another method, which is a combination of parallaxes. So, kay hindi pa ng trigonometric parallax, para pa ng other method. Para pa ganyan silang gitawag na karapitang parallax, nga naka-base sa color, which is gitawag nila spectral parallax, spectrum of light, colors of light, ilang basihan para mapa nila ang distance sa object. Okay, so far, we learned that use this method, the triangulation and the radar imaging, in measuring the distance of and we will use parallax for nearby stars and combination of parallax for distances beyond 100 parsecs and up to the midway. Kung ang aton ang aton Milky Way galaxy, ang parallax ang iyang ma-measure, kung ano nilang Earth, ang iyang ma-measure, total lang sumatunga. Di na siya kadamos, patikas. So, because of that, they devised another method to measure the distance of celestial objects beyond 10,000 parsecs. And that method is called the standard candle method. So, the standard candle method is mainly used for the galaxies. So, starting with the more distant part of the Milky Way galaxy, then the nearby galaxies, and then the galaxy superclusters. Okay, next, in using standard candle methods, what law of light shall be used to determine the distance of the star from the Earth? The inverse square law. Okay, so ano man na siya ang inverse square law? Ang inverse square law states that the intensity of light to an observer from a source is inversely proportional to the square of the distance from the observer to the source. So, inversely proportional. In mathematical statement, ang na siya ang iya relationship. I, for intensity, is 1 over ganing inverse na siya. The inverse of 4 is 1/4. So, inversely proportional inversely proportional of the square of the distance, that is 1 over the square of the distance. So, ano na siya ang iya mathematical statement. And in equation, kung ato siya i-translate into equation, ano siya i-approve? Intensity is equal to constant times 1 over the square of the distance. Or, in short, I equals constant heat over the square of the distance. May formula. Okay, so we'll make use of this illustration. Isa. We have your candle. The candle, ang iyang light, ang iyang intensity of sunlight niya is 16 photons. The 16 photons intensity of the light of the candle is the constant. As the light travels to a longer distance, ano siya may tabo. You notice that starting with 1, 16 pa. Then, pag travel niya longer distance, abot nito sa 4, minimum 1 na lang ang iya intensity. So, ang relationship ngayon sa inversely proportional means nga, as the distance increases, the intensity decreases. Sa ato pa, kung ang object is moving away from the viewer, ang iya light, mag-decrease ang intensity. Kung in another nga pagka-state, ang light, for example, light sa plus light, kung mag-travel na siya palayo, as it travels away from the source, which is the bulb of the flashlight, na makita po, mo-decrease lahat ang iya intensity. Mas stronger ang iya intensity, nga closer sa source, then papatyagan pa rin mo ang kainit niya, paano mo ang kasilaw niya, pero kung magkalayo ka, mag-decrease na lang ang iya intensity. Tama na siya ang inverse square law. For the demo of the inverse square law, I will prepare na projector. Then, pag sit up, magpatabang ko, para i-prepare na kung saan niyo muna ako. So, break. Let's start from 1. Sit up next. Yan. Ikaw man mo kasi. Brightness or luminosity of reflected light therein as the projector is moved away from the board. Okay, it decreases. So the decrease ang iya luminosity. Then, for example, kung ang iya ang constant, actually, gamay rin siya ang ikuan. Kung nangitan o 1,600 lumens ang intensity sa light sa projector. Actually, ang projector mo na siya 4,000 lumens. So, for example lang, 1,600 lumens. Ang iyang constant, ang iyang brightness sa bulb sa projector. So, dire, ang iya ang 1,600 na lumens concentrated dira na yun. Ano din tanan ang 1,600. While pag move into 2 feet, ang may tabo, ang 1,600 na divide sa akin siya upat. Tama na siya nga ini siya 1 ari 1 fourth. Ito pa, i-divide by 4, 1/4 kada. Ang iya intensity is 1/4 na lang sa 1,600 lumens. Then pag nabot ka rin, nahimong 9 kay tanawag, na-divide siya into 9 squares nga kung pare-pareha niya kadakon. So, sa ito pa, ang 1,600 na-divide into 9 siya ka parts ang iya intensity. And then kaya sa 4, na-divide siya sa 1/16. Sa ito pa, kay 1, 2, 3, 4, 4 lang kaya 16. So kung ninyo tanawon, this is 2 squared, this is 3 squared, this is 4 squared. 4 times 4, 16, 3 times 3, 9, 2 times 2, 4. Inversely proportional sa iya distance. Ang distance nila is 1, distance nila is 2, distance nila is 4, 3, 4. Ang iya last divisor is the square of the distance. Distance is 2, square of 2 is 4. Dire, distance is 3, the square of 3 is 9. Dire, distance niya is 4, the square of 4 is 16. Siya ang pagpasabot sa inverse square law of light. Modified into the square of the distance. So, sa ini siya mga table, makita ninyo, ano nga gagawin sa distance niya 1, 2, 3, 4, 6, and then ang iya divisor is square of the distance lang. So, kung tanawin ninyo, kung compute na siya, the competition will be, ang ulit, dire ang iya intensity is 1,600 lumens, while din ang kada usa niya part, ang iya intensity is only 400 lumens. While dire, ang iya intensity is 177.7, actually, paano siya, repeating 7. And then, sa ikaw ang kada usa sa ila, ang iya intensity is only 100 lumens. So it means nga, magkalayo ang light, ang iya brightness or intensity sa light, including ang iya temperature, ang brightness, mo decrease pa siya. So kung araw kalapit sa light, kung inito siya, hindi ko makapasok, pero pag ka sa layo, di na. Kung araw kalapit sa light, kung mga kalapit na, di ba init na siya, so panito na ka kung sa init, pero kung layo na ka, although nakabot ang light, pero di na kayo, hindi mo mapatyagan ang init. Because ang iyang intensity, hindi nga decrease na. The same happens to light. The stars. Ang mga siyang naitabo. Magkalayo siya, ang iyang intensity, ang iyang light, iyang brightness will decrease, ang temperature lang niya will decrease. While compared sa sun, ang mga pinakalapit na star, kung sa iya distance, kung sa iya kalapit, ang iya temperature at pamabatyagan iyang itol. Kung ipalayo lang na ang sun, hindi ka natin mabatyagan. So ano siya na sa iba ng mga iba ng mga planets na lapit na, at are the formations of ice. As per the inverse square law, light loses its brightness or luminosity as it moves away from the source. For the nearby galaxies, what standard candles are most useful? Okay, 6 Cities is the most are the most useful for nearby galaxies. Up to what distance can the seepage be used? Okay, up to 100 million light years away. Anak ka tayo 100 million light years. Kung ato na ikuan sa kuan, kung ato i-convert into kilometer, quadrillion na pati naman yung makayo. Okay? Siemens can be used to approximate the distance of stars and galaxies up to 1 million. Sa ito pa na siya, 100 million light years. Amo na yung limit. Hindi na siya magdakaw. So, for longer distances, ara na sa nilain nga standard candle nga ilagang ito. So, what standard candles can be used for very far galaxies? Okay, white dwarf, supernova. Supernovae. Ang white dwarf supernova, ang na siya ang gigamit nila para measure sa distances sa very far galaxies. Tungod sa idea nga ara siya sa peak luminosity. Ang supernova magod, gikan na siya sa main sequence stars. Ang nagyan ko niya kadako, wag siya mo dako mga yung pareha sa mga giant na mga supernova. Ang iyang kadako pareha lang yapon sa main sequence star, pero niyabot na sa stage nga supernova. Kung sapa na siya, gikan sa iya kuan, baka natiguwang siya, wag siya mo dako. So, using their brightness, ang iya characteristics, ang hindi gamit nila nga data para ma-determine nila ang distance sa other nga mga celestial objects, sinang nga galaxy. So, ano siya ang katagawa na, for the solar system, gamit sa revolution method and rearranging method, which is a direct method. Modern na siya radar. While for the nearby stars, we use the parallax up to the midway of the Milky Way galaxy. Diyan, nagamit na sa standard candles. So, ang iba ng mga astronomers, nagamit sila sa mga main sequence star. Ang iba nagamit sa mga CPICs for the nearby galaxies, both nearby and the galaxies and siyang mga celestial objects sa Milky Way. Kag, kung lagi na kayo, nagamit na sa the white dwarf supernova. Okay, so let us wrap up our lesson. This is a true or false assessment or evaluation. You are going to give your answer by sign language of true or false. So again, true is, and then false. Ready? Show your answer in 3, 2, 1. Okay, so the answer is true. Number 2. Okay, show your answer in 3, 2, 1. Okay, so okay, the correct answer is false. Within 100 parsecs is parallax. Number 3. Your answer in 3, 2, 1. Okay, everybody got the right answer. True. Show your answer in 3, 2, 1. Okay, so everybody got the right answer. Cool. So the right term for this description is CP. For the application of the lesson, this application will serve as your assignment. In our modern technology, we know that it is still impossible to travel back in time. Diba? Natin yung mga time machine, but that is only a theory, mga fictitious story. Pero in reality, wala maging nakatravel back in time. Then, alis ang quotation ng suki, you can look back in time every time you look at the stars. So, what is your idea about this? Do you agree or do you disagree? So, your output for this will be through a creative presentation. Either your presentation of your choice. If you think you can express your idea through illustrations or drawing, you may draw your idea. Or you may make a poem, or write an essay, or write a short story. Kung may lang istorya, you write in a short story. Or video recorded of a monologue. Or you can write or record a song. So, So, ang idea is looking back in time as you look at the stars. So, di ba tayo magpaanda ka ng gabi, aktuan, walay mga panganod, tanong sa mga bituon sa ano yung mga memories ng ating mga recall ka. So, we can create stories about that, mga bala, mga that. So, ano na siya is yung output. Okay, output must be submitted on Wednesday. Okay, for the assessment, the assessment will be given next time. So, on Wednesday. Okay, let's go to the lessons we may learn from the start. So, I will give you 2 lessons from the start. The first one is taken from this picture. Actually, this is a picture from Google. Akong i-download, pinapakita sa inyo. I would like to emphasize this part. Every one of us, no matter who we are, is equally important. Simply because we are all a shining star in someone's life and universe. And most importantly, our own. So we are a shining star. Importante that we are unique para sa mga stars. We have a special place in this world. Pagkarin natin sa libutan sa kailangan ng mga talents. And our talents have special place in our world. So tayo na sa shining star. Tingali, atong talents wala natin appreciate, but there is someone who can appreciate and need your talent. That is the first lesson from this part. The second lesson is that taken from Psalms 19 verse 1, the heavens declare the glory of God. The skies proclaim the work of His hands. So, ang mga bituon, di ba, nasa kasukti, they have no language, but they were able to glorify God through the brightness. Ano bang beauty na ilang ipakita panahon sa agam-iyo? Then, the same lands about. Even without language, we can glorify God. So, in the same way, let your light shine before others, that they may see your good deeds, your good works, and glorify your Father in heaven. So, like stars, ato daw shine as a light. Let our good works be seen before men. Ipakita natin good works nga to sa mga tao. So, So, dua ka lesson. First lesson is that we're important, we are special, and we have unique personality, and we are given with special talents. And then second, we will make use of that talent to glorify God by serving those who need our service. So, ako na siya na lesson from the slide. Okay, so that is the end of our lesson. Prepare for the assessment on Wednesday. And don't forget your assignment. Okay, that's all for today. Goodbye, class.
Goodbye.